Look at this vintage mainframe. Without human-written instructions to tell it exactly what to do, it is an expensive metal box. System software provided the rigid structure necessary to run the machine, but the computer could not think for itself. Artificial intelligence software moves beyond those rigid instructions. It combines computer and data science to automate problem-solving, creating systems that refine their own accuracy and adapt as they process new information. We saw a major milestone for this technology when IBM's Watson defeated the world's best Jeopardy contestants. It proved that a machine could finally master the nuances and speed of natural human speech. That ability to interpret massive volumes of data quickly moved from game shows into healthcare, finance, and law. Today, because these systems influence almost every sector of the economy, the challenge for a manager is understanding the underlying frameworks that drive these automated decisions. Failing to grasp how AI actually works leaves you as a bystander, while your competitors use these systems to scale their operations and automate complex tasks. To build an AI model, businesses need a roadmap. The IBM AI Ladder uses 4 sequential steps: collect, organize, analyze, and infuse. In the first 2 steps, a business gathers raw data and structures it reliably so algorithms can actually search through it. Imagine an HR department trying to predict employee turnover. They need internal data, like current salaries and past performance reviews, combined with external data, like competitor pay rates pulled from public websites. If that initial information is incomplete or disorganized, the predictions will fail. An AI model is ultimately only as intelligent and reliable as the data foundation it stands on. This diagram breaks down the disciplines of artificial intelligence and data science. Here we reach the third ladder step, analyze. Notice the overlapping circle for machine learning, a subfield where algorithms use data to gradually improve accuracy over time using human inputs. A retail store might use machine learning to build a dynamic pricing model. By analyzing current inventory, past sales records, and upcoming weather patterns, the system calculates the exact price to charge for a winter jacket to maximize profit. Nested inside is deep learning. This uses neural networks, a layered structure of input, hidden, and output nodes designed to mimic the human brain. This allows the system to process complex data with far less human intervention. On a manufacturing assembly line, a deep learning neural network can analyze thousands of digital images in real time, instantly spotting microscopic product defects that a human inspector would miss. The analyze step represents the critical transformation point. It is where passive data storage becomes an active engine capable of making predictive decisions. The final step of the ladder is infuse. This is where the AI is integrated across the organization's daily operations to solve real problems. Traditional AI predicts specific outcomes based on rigid rules, like calculating a trend line. Generative AI creates entirely new content, like drafting a document. To control generative AI, managers use prompt engineering, structuring prompts with a task, context, and references to generate exact outputs. For example, a marketing manager might review the sales predictions generated by traditional AI and then write a precise prompt instructing generative AI to draft targeted email campaigns based on those exact predictions. Infusion is the ultimate goal of this entire process. It represents the moment a business finally realizes a return on investment from all their initial data collection efforts. But there is a severe risk built into the AI ladder. If the initial data collected in step 1 was flawed or prejudiced, the final infused output will be dangerously biased. Algorithms look for patterns in historical data. If society's past decisions contain discrimination, the AI system will simply learn and reinforce those unfair historical trends. Look at this funnel. If a company trains an AI resume screener using only the historical data of successful hires from one specific demographic, the system will learn that those specific traits equal success. It will automatically filter out diverse candidates before a human ever sees their application. Because of these risks, human judgment and transparency are mandatory to police AI ethics and maintain public trust. High-profile tech leaders continue to warn about the dangers of deploying unmonitored AI without strict human oversight. This defines the modern manager's ultimate mandate. Your job is not to code the AI. Your job is to strategically deploy it, engineer its prompts to get useful results, and actively safeguard its ethics. Think of a business you interact with regularly. How could they implement an AI framework to solve an inefficiency in their operations? And more importantly, what human safeguards would you require them to have in place?